Hey everybody, this is Unit 3, Video 3. We're going to be working on factoring perfect cubes, something you probably didn't get to see in your Algebra 1 class, so take good notes. Here we go. Alright, so what are perfect cubes? Similarly to perfect squares, you're going to take any number you want and cube it. But we're going to talk about the ones that are most common, because you probably now, whenever you see the number 49 or you see the number 81, you automatically associate it with it being a perfect square, and that's really good. So we're going to introduce this next group of numbers that I want you to eventually become so familiar with that every time you see it, you also relate it to being a perfect cube. So just starting at the basics here, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. Of course, there's many more. Another popular one we probably will see is 10 cubed, and 10 cubed being 1,000. Doesn't mean the ones I skipped aren't important or that there are some that aren't up here, but be familiar with these as they're the easy ones to cite. You can always check them in your calculator. But then we have to look at some perfect cubes as being exponents. So what about x cubed, just a variable cubed? Another perfect cube would be x to the 6th. So how is that a cube? Well, using our exponent rules, if I have x cubed, or x squared, cubed, then this is a perfect cube. So how about x to the 9th, which is x cubed cubed, or x to the 12th, which is x to the 4th cubed, x to the 15th, which is x to the 5th being cubed. So if you notice, there's a big pattern going on with our exponents. Okay, so the first thing I want you to do here is I'd rather you pause the video and try to expand x plus 2 quantity cubed, and then check back with me, and then try x plus 2 times x squared minus 2x plus 4, and then check back with me. But don't watch me do them, just try them on your own. Okay, so how did you do? I got x cubed plus 6x squared plus 12x plus 8 after multiplying it all out and collecting like terms. Alright, go ahead and pause it now and try the second example here, and then we're going to talk about them. Okay, after all my multiplying and combining like terms was done on the second example, I got x cubed plus 8. So what I get with that is I actually have two perfect cubes. I have x cubed and 8, which is a perfect cube. So what this is going to show us is that just because I have perfect cubes doesn't mean that I can take a quantity and cube it and get a result that has perfect cubes in it. It does have perfect cubes in our first example, but then it has these other two quantities. So we're going to be using something similar to this as we factor. So here are my rules for factoring perfect cubes. Unlike perfect squares, where we could only use the difference of perfect squares because our sum of perfect squares gave us unreal answers, we're going to be able to do both sums and differences because they're a little special. So here is our rule. I will have a cubed plus b cubed. That's what I'm going to start with before I factor, where both a and b, or a cubed and b cubed, are perfect cubes. Okay, so I first will factor this to be a plus b times a squared minus ab plus b squared. And this is the results of factoring a cubed plus b cubed. You must identify what a and b are. For example, if I have x cubed plus 125, I will identify a to be x, that's what's being cubed, and b in this case will be 5. So when I go to substitute those values into my rule, then I'm clearly going to put them in the correct position. I'm not substituting in 125 and squaring it, I'm substituting in b equals 5 and squaring it. So the difference of perfect cubes is very similar. I will have a cubed minus b cubed as my setup, and the result here will be a minus b times a squared plus the product of a and b plus b squared. Once again, you have to identify what a and b are in order to substitute them in correctly. For example, if I give you the numbers or the expression, let's go 64 minus x to the 6th. In this expression, my a value is going to be 4 because this 4 cubed is 64, and my b value is x squared. Once you have those identified, you'll be able to correctly substitute them into the rule using either the difference or the sum of cubes. Make sure you have those formulas handy, because I'm going to ask you to try numbers 53 to 61 odd involving factoring perfect cubes.